In this video, I'm going to work through 3 examples of finding the equation of a hyperbola. Now, the examples differ in the information that is given. So look carefully at what information is given in a graph and how I use that to find the equation. So, example 1 says consider the graph of f of x equals a over x plus p plus q. Determine the value of a, p, and q, which is a way of asking you to find the equation. Okay, now in this graph, you'll see that we are given the equations of the asymptotes. X equals 2, y equals 4, and then we are given the coordinates of one point that lies on an arm of the hyperbola. Okay, when this information is given, the equation of the hyperbola is quite straightforward to find. Okay, so start with the asymptotes. The horizontal asymptote, y equals 4, gives you the q value. So we know that therefore q equals 4. From the equation of the vertical asymptote, x equals 2, we find the p value. Now, p is not 2. Okay, so to find the p value, what I do is bring everything to one side of this equation. So if we subtract 2, I have x minus 2, and then I'm left with 0 on the one side. This x minus 2 is what you would substitute into your denominator of the equation. So if x minus 2 is equal to the denominator, which is x plus p in this case, it means that p is negative 2. Okay. Now, I write in this information into my formula. So I have y equals a over the denominator is now x minus 2. My q value is 4. Now, the only unknown is a. Now, if I have one unknown in an equation of a function, I have to substitute 1 point to solve for it. So I'm going to substitute the coordinates of the point that we're given. So substitute for 7. So y is 7 and x is 4. So I have 4 minus 2 in the denominator, then I add 4. So my denominator is now 2 plus 4. Solving for a now, 7 minus 4 is 3, equals a over 2, multiply by 2, and we get a is equal to 6. Okay, now this question said determine the values of a, p, and q. So I've got q equals 4, p equals negative 2, and a equals 6. Now that would be the answer to the question, okay? But often there's a following up question in which you use the equation of the graph. So it is always a good idea to, despite having to answer the question with the values of a, p, and q, to write out the full equation. So a is 6, then the denominator is x minus 2 plus 4. That would be the equation of the hyperbola. The second example says determine the equation of the hyperbola shown. Now, in this graph, we are not given the equations of the asymptotes. We are given the coordinates of the point of intersection of the asymptotes. Okay, but the coordinates actually give us the equations of the asymptotes. We have x is 5, so x equals 5, and y equals 2. Now, since a horizontal line has the same y coordinate everywhere on that line, this equation is equal to the y coordinate that is everywhere. So the equation is y equals 2 of our horizontal asymptote. And the same for vertical line. The x coordinates are the same everywhere. So the equation of the vertical line is x equals that coordinate. Okay, so the point of intersection gives us the equation of the asymptotes, and then we use those in the same way as in the previous example to find the q and the p value. So from y equals 2, I have that q equals 2. From x equals 5, I'm going to bring it all to one side, so I get x minus 5 equals 0. Okay, so this is what I write in the denominator of the equation of the function. And if I needed to find the value of q, if x plus p is the denominator, then my p would be negative 5. But we are not really asked for that here. Okay, so I know the q value and I have the denominator, so I can write out what I know so far. Y equals a over x minus 5 plus 2. Now I have one unknown, which is a, so I substitute 1 point on the graph and I solve for a. So substitute, and always write down what you are going to do. Tell your reader what you are doing so that they can really follow your working. Okay, so substitute 3, 3. So y is 3, that equals a over x is 3, so it's 3 minus 5 plus 2. Solve for a. 3 minus 2 is 1. A over 3 minus 5 is negative 2. So multiply by negative 2, and we have a equals negative 2. So the equation of the hyperbola is y equals a, which is negative 2, over x plus p, which is x minus 5, plus q, which is 2. Looking at this third and final example, we are told to determine the equation of the hyperbola shown. Now, in this hyperbola, we are given the equation of the vertical asymptote. We are not given any information about the horizontal asymptote. And then we are given 2 points on the hyperbola. Okay, so always start with your asymptotes. So from x equals negative 4, we can find the p-value. I bring everything to one side, so I have x plus 4 equals 0. And this is what goes in the denominator of my equation. So in this case, if x plus p is my denominator, p is 4. Okay, so I have y equals a over x plus 4 plus q. Now, I still have 2 unknowns that I need to find. And for any function, if you have to find the equation and you have one unknown, you substitute 1 point. If you have 2 unknowns, you have to find you substitute 2 points to find 2 equations which you solve simultaneously for those 2 variables. If you have 3 unknowns, you can substitute 3 points, find 3 equations to solve simultaneously to solve for those 3 variables, and so on. We need to substitute 2 points, set up 2 equations to solve for 2 variables. Okay, so I'm going to substitute the coordinates negative 3, 7. And always tell your reader what you are going to do so they can follow your working. So y is 7, so I have 7 equals a over x is negative 3 plus 4 plus q. Simplifying this, I have 7 equals a over negative 3 plus 4, which is 1, so that fraction falls away, plus q. Okay, and I'm going to label this my first equation. Then I'm going to substitute the coordinates negative 7, negative 5 into the original equation. Okay, so I have y, which is negative 5, equals a over x, which is negative 7, plus 4 plus q. Simplifying this, I have negative 5 equals a over negative 3 plus q. Okay, let's get rid of the fraction, so I'm going to multiply by the denominator, negative 3. So negative 5 times negative 3 is positive 15. Then this is a. Q minus times negative 3 is negative 3q. Okay, now looking at the 2 equations that I have 2 unknowns. So there are 2 methods that you can use to solve them: elimination or substitution. If you know how to use elimination, by all means go for it. But I'm going to show the working here using substitution, because while you can only sometimes use elimination, substitution is a method that you can always use. Okay, so what I want to do to use the method of substitution is I need to solve for one variable. So in this equation, I'm going to solve for a. So I'm going to add 3q, and I have 15 plus 3q equals a, and I'm just going to rewrite it so it's easier to see for some of us. Okay, and that is my second equation. So I'm just going to put a box around them so I can see them clearly amongst all this writing. And maybe you could highlight yours, okay? Now, I need to solve for a and q, so what I'm going to do is I'm going to substitute the second equation into the first equation. And I tell my reader what I'm going to do. Substitute 2 into 1, okay? So, wherever there is an a, I'm going to substitute 15 plus 3q. So I have 7 equals a, which is now 15 plus 3q. And then I still add the q. That gives me an equation with only one variable, which I can solve for. 7 minus 15 is negative 8. 3q plus q is 4q. Divide by 4, and we have that q is equal to negative 2. Okay, now I can substitute the q value into either one of the equations to solve for a. And I'm going to choose the second equation because this one has a as the subject of the formula. So, substitute into 2, and we have a equals 15 plus 3 times q, which we found to be negative 2. So that gives me a equals 15 minus 6, which is 9. So I have the q value and the a value, so I can now write out the final equation. Y equals a, which is 9, over the denominator was x plus 4, and then I add my q value, which in this case was negative 2, and I have the equation of the hyperbola.